So here is our 2-2 climate zones. And we've already been talking about climate and how that is determined by the average temperature and average precipitation in a region. Now we're going to talk about climate zones. And climate zones, they're divided by just their average temperature. Right, so within each zone, you're going to be having some division with precipitation, so that would give you a subzone. And even into the subzones, you can divide that into smaller areas called microclimates. That could be your city, it could be the state, it could be your own backyard. Now there's three major zones that we're going to look at. The first one is the polar zone, also called the Arctic climate or often the mountain climate. Now, the polar zone, that is between the 90 degrees and 60 degrees. And remember, 90 degrees is our North Pole. The average temperature in the polar regions is going to be about equal to or less than 0 degrees Celsius, so it's pretty cold. That's, the North Pole where Santa and everybody else is. Very little precipitation. In fact, the poles can be described as deserts. We usually think of deserts as very hot, but deserts are just places with very little precipitation, and so you can have a very cold desert. Polar zones, that's going to be like the ice caps in Greenland. It's going to be the glaciers at the north and the south poles of the Earth. Now we can also have temperate zones. Now the temperate zone is between 60 degrees latitude and 30 degrees latitude, and we talked about this in class. If you don't remember these degrees, I want you to take a minute and I want you to review it, because this is definitely something that I'm going to want you to know. Now in the temperate zones, there's a big range. You can have snow in winter, that's closer to the 60 degree latitude. You can also have rain year-round. That's closer to the 30 degrees because it's warmer closer to the equator at 30 degrees. There's a wide range of temperatures, anywhere from an average of 5 degrees Celsius, that's up north, or south, closer to the 60 degree mark, or up to about 20 degrees Celsius, that's, closer to the 30 degree mark. And the 30 degrees latitude, that's, across where we would have Florida, middle of Texas, through the top part of Mexico, and that's generally a warmer climate. Now also in the temperate zone, like I said, there is a big range. You can have cool rainforests, like in Washington. You can have hot rainforests, like South China. You can also have deserts, like in Australia and Central Asia. So here's a question for you. Why are the deserts, at least in the temperate zone, why are those deserts so hot in the day and so cold at night? And also, I want you to think about what lives in the desert. Go ahead and pause the video and take a look in your book. I'll expect you to know those. Now, our tropical zone, that is the closest to the equator. So 0 degrees is the equator, up to 30 degrees latitude. There's very high temperatures and very high humidity. That's where we're going to have our rainforests. This is the warmest zone. There is no winter right in the middle of the Earth. And the deserts in the tropical zone are going to be on the west coast of whatever continent. And the winds in the tropical zone tend to come from east to west. So here's another question for you that I want you to pause the video and find out the answer to. Why does the fact that the winds go from east to west in the tropical zone, why does this explain that the deserts are on the west coast? So think about what we've already talked about with our wind direction and precipitation, and find a reason or find why that the winds go from east to west explains this. Now, all of our zones have two major types of climates. They can have a marine climate, I've written in blue, that has to do with water, and they can have continental climate, written in green, that's to do with land. The marine climates are near ocean. There's more precipitation, which should make sense. They're close to water, so the air is wetter. The temperatures don't vary very much, meaning that you don't have big swings in temperature. Believe it or not, we here are in a marine climate because we are so close to the Great Lakes. Continental climate, and that's going to be those that are inside the large land masses, like in the center of a continent, they're going to be drier. There's going to be a large range of temperatures. So if you think about the U.S., there's a much larger range of temperatures in the middle of the U.S., like Colorado, than there is at the coast. Now, for everywhere on Earth, there are 4 seasons, but not everywhere on Earth experiences them the same way. The 4 seasons are caused by the tilt of the Earth's axis, meaning that the Earth's axis is at an angle. Now, when this axis is pointed towards the sun, that's when that area of the globe has summer. If the axis is pointed away from the sun, that's when the area of the globe has winter. When it's spring or fall, that means that the axis isn't pointing towards the sun or pointing away from the sun. It's just parallel. So here's a picture of the Earth that I have drawn. So you'll have to have some patience and squint your eyes a little. Here's the sun in the middle, and this is supposed to be the Earth. Now these lines that I've drawn out, these are the poles. This is our north and our south pole. Now the Earth rotates around the sun in this way. The axis doesn't change. Well, for us it doesn't change. Later you'll learn that it kind of wiggles a little bit. So when the North Pole is pointing towards the sun, then the northern hemisphere is going to have summer. And when the North Pole is pointing towards the sun, the South Pole is pointing away, meaning that the southern hemisphere is going to experience winter. When we rotate around a little bit, over here, the poles, they aren't pointing towards the sun or away from the sun. They're just sort of at an angle. And this is where you're going to have fall and spring. In the northern hemisphere, it would be fall because it's getting colder and moving away from the sun. In the southern hemisphere, you're going to have spring because you're starting to get closer to the sun. When the South Pole points towards the sun, then the southern hemisphere has summer. The northern hemisphere has winter. So this is going to occur in December. That's what we're used to. But it's why down in Australia for Christmas it's really hot, because it's the middle of summer for them. When it continues rotating, the northern hemisphere is going to start getting warmer. That's when we get our spring. That's around in March. And our northern hemisphere gets warmer, so we get spring. The southern hemisphere gets colder, so you have fall. And then you rotate again back around. So this is why the northern hemisphere and the southern hemisphere have opposite seasons. Now, right along the equator in that tropical zone, from 0 degrees up to about 30 degrees or down to about 30 degrees, so that band in the middle, you do not have fall or spring. All right, you don't have these seasons. Even though it rotates through this spot, the middle of the Earth doesn't really go much farther away from the sun. So what you have there is you will have a rainy season and a dry season, but you don't have winter or spring or fall. You have summer, which rains or doesn't rain. All right, so that's it for 2-2, and we're on our way to finishing up this chapter.